Okay, guys, let me solve this. So, A is the radian measure of the smallest angle in a 3, 4, 5 right triangle, and B is the radian measure of the smallest angle in a 7, 24, 25 right triangle. In terms of alpha, what is beta? Okay, so this is a 3, 4, 5. This is a right angle, which means, yeah, okay, I'll come back to that. This is a 7, 24, 25, and if we were to make this more straight, we can see that this is of course the smallest angle. So this is beta. Um, and then as you can see here, this will be alpha. I'll make this a straight line too. Oh, let's make it a straight line. Yeah. Okay, so and then this is alpha. So alpha is equal to the tangent of, I don't know, would it be the, yeah, it'd be the inverse tangent. Alpha is equal to the inverse tangent of SOHCAHTOA, so 3/4. And beta is equal to its inverse tangent of 25/24, which is equal to the inverse tangent of 3 over, no, you can't take 3/4 out. But what you can do is you can just do tangent of beta is equal to 25/24. If this helps at all. But I need to find alpha in terms of beta. Or find beta in terms of alpha. So, what I really should do is, I mean, I can keep this here. What I'm going to want to do is I'm going to keep this one and I'm going to have to reverse this one. So I have tangent of alpha equals 3/4. And then, somehow manipulate that into here. Let's look at these answer options. So we have alpha over 3, and just looking visually, does this make sense? Alpha over 3. Yeah. Alpha minus pi over 8. Yeah. Pi over 2 minus 2 alpha. Okay. The thing is, pi over 2 is 90, and 2 alpha. Alpha is going to be like 50 something, I think. Or like, sorry, it's going to be 30 something, 40 something. So if we, or in degrees, I'm saying. So if we have that'd make this like 1020, which I don't know about that. But, no, okay, I could see that. And then pi minus 4a. Again, let's say a is like 30, then that would make sense, yeah. A is 40, then that makes sense. Okay. And alpha over 2 makes sense too. There has to be some identity for tangent that I'm like totally forgetting. Oh, there is tangent squared. There's 1 plus, yeah, 1 plus tangent of x or theta is 1 plus tangent squared of theta is equal to, here we're dividing by x, so we would do cosecant, no, we do secant theta squared. So, okay, that might help. Why don't we square this? So we have tangent squared of alpha is equal to 3 over 4. Or is equal, what am I talking about? Is equal to 9 over 16. And then we have tangent squared of alpha is equal to secant squared of alpha minus 1. So, or of theta. So here now we have secant squared of theta. I'll just add the 1 to this side till we get 25 over 16. So secant theta is equal to 5 over 4. This isn't really helping though. Because we need something for inverse tangent, and that's like what we're not getting. That's what we need. That's what I'm not getting. From what I remember, I believe this is about like 56 degrees, which would make this like, it'd be like 40 or 34, right? 460, yeah. This would be 34 degrees. I have no idea about this. But if I were to just, I'm using my hand. This does look like it's about to scale. And then this angle, I can't really tell. I'll make a straight line here. See, look, that's very thin. So 34 over 3, no, that's too little. Pi over 8, which would be 180 over 8, which is yeah. Okay. No. Yep. Okay, yes. So this gives me 45 over 2, which would be 22.5 degrees. So, yeah, that's too much. Or it's too little again. 90 minus 2 times this would be 90 minus 68, which is 22. That's possible. This is like 17. No, I'm not gonna say that one. Then that'd be 180. Is this just the same thing? Yeah, this is just the same thing. So neither of these can be true. So I'm gonna say it's this one, D. Because I'm making an educated guess here, because I really have no idea how we're supposed to solve this one. Oh, it's C. Interesting. How did he get this? So they got sine, cosine, and sine of alpha, cosine of alpha, and sine of beta, in cosine of beta. Then they said sine of 2 alpha, they did the double angle formula, and then they got sine of 2 alpha. And then they just found it's equal to cosine of beta. But, like, I don't know how you know that. They just, like, figured that out. Anyways, um, which is equal to sine of pi over 2 minus beta, and somehow from that they got 2 alpha is equal to 2 alpha is equal to pi over 2 minus beta. Gosh. But really what they did that I didn't do is they used the double angle identity, which I would have never thought to use. Because, like, why would you use that? Like, why would you think? Sure, you could think to use it because it's angles. But why would you know that it gives you an equality? I don't know. But thank you guys for watching. I'll see you guys tomorrow. Goodbye.